bitwise operators, and in the previous tutorial we discussed about bitwise AND, bitwise OR, bitwise XOR, bitwise complement operators. Today in this tutorial we'll discuss about shift operators. The bitwise shift operators are used to move or shift the bit patterns either to the left side or the right side. That's why we have two types in this shift operator, that is left shift operators and right shift operators. So first we'll talk about the left shift operators. So the symbol used for left shift operators is this. This operator is used to shift or move bits towards the left side. And this operator is also used with two operands, and you can take any name for the operands. Here I'll take x and n. Here x is the value which you want to shift and n is the number of bits you want to shift. For example, if I take x as 20 and number of bit I want to move is 1. So here n value is 1 and 20 is nothing but the x value which you want to shift. So here what it will do is it will shift the bits of 20 towards the left side by 1 bit. So I'll show you how this works. So the binary representation of 20 is nothing but 0, 0, 0, 1, 0, 1, 0, 0. And we need to apply left shift operator. So what happens is this bit will be popped out, because here we can see we are moving or shifting the 20 towards the left side by 1 bit. So this will be popped out and this bit will move here and this will move here and this bit will move here and this bit will move here, this bit will move here and this bit will move here and this bit will move here. In the left shift operator, n number of bits are popped out in the left side. So this is the left side and this is the right side. And at the right side we can see n number of empty places. Here n value is 1 because we are shifting the 20 by 1 bit. That's why here we can see one place is empty. And we need to fill this empty place with the 0. So this is the result of this operation. So here this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. 1 is present at 2 power 5 and 2 power 3. 2 power 5 is 32 and 2 power 3 is 8. So total 40. When we shift 20 by 1 bits, we'll get the result as 40. And as I said previously, it is better to use these bitwise operators with the unsigned operands. Most importantly, if you are using bitwise shift operators, then apply these operators on the unsigned values. Because if you apply bitwise shift operation on the signed values, the result of that is implementation dependent. When we apply this bitwise left shift operators on the signed values, we may face undefined behavior or the overflow condition. So it is better to use this bitwise left shift operator with the unsigned values. So I'll show you the example for this. Here I'll take A as 20 and here I need to perform left shift operators, so by 1 bit. So let's execute this. We got the result as 40. Or you can shift this by 2 bits also, like this. We'll get the result as 80. So if you want to do this manually, then so this is the binary representation of 20, and now we need to shift 2 bits here, right? So the first bit is popped out and the second bit is popped out because we are moving 2 bits. So next 0 comes here and 1 comes here, 0 comes here, 1 comes here, 0 comes here and 0 comes here, and the last 2 bits are empty, and in that places we'll add 2 zeros. So this is the result. So here in the 2 power 6 we have 1 and 2 power 4 we have 1. So 2 power 6 is nothing but 64, 2 power 4 is nothing but 16, so 80. So we got the result as 80. Okay, so in this way bitwise left shift operator works. Next we'll talk about the bitwise right shift operator. So the symbol used for right shift operator is this. This bitwise right shift operator shift or move bits towards the right side. And this operators also works with the 2 operands, and here I'll take operand names as x and n. Here x is nothing but the value which you want to shift, n is nothing but the number of bits you want to shift. If I take 20 and n value as 2, we are moving 2 bits of 20 towards the right side. So the binary representation of 20 is 0001, 01, 00. And now we need to move these bits towards the right side by 2 bits. Okay, the first bit is popped out and the second bit is popped out, and 1 comes here and 0 comes here, and this 1 will come here and this 0 will come here, and this 0 will come here and this 0 will come here. And at the left side, this is the left side and this is the right side, and at the left side we can see 2 places are empty because we are moving the 20 towards the right side by 2 bits. Here 2 bits are empty. Now here we need to add 2 zeros at the left side. So this right shift operator shift or move bits towards the right side, and in the right side the n number of bits are popped out, and in the left side n number of zeros are added. The empty places are filled with zeros. If you are using unsigned values here, if you are using unsigned values, then only at the left side you need to fill the empty places with the zeros. If you are using this bitwise shift operator with the signed integers, signed values, then the result of this is implementation dependent. In most of the cases, when we apply bitwise right shift operators on the signed values, for the positive value it will add 0 in the left side, for the negative value it will add 1. The empty places for the signed values, if the value is positive, then the empty places will be filled with 0. If value is negative, then the empty places will be filled with 1s. So I'll show you the example. First we'll take the example for unsigned integer, and here I'll take a. I'll do right shift operation now. So let's execute this. Result is 5. So here we can see this is the result which we got after applying the bitwise right shift operator on the 20 when we moved 2 bits. Here this is 2 power 0, this is 2 power 2. So 2 power 2 is 4, 2 power 0 is 1, so 5. This is the result of 5. That's why we got 5 here. And if you want to apply this right shift operators on the signed integers, here I am assuming that for positive value it will fill the empty places with the zeros, and for negative value it will fill the empty places with 1. So let's see the example for that. So here we have 20, so use right shift operator, and I'll apply this first on B. Okay, B is a positive value, right? So let's execute this. The value is 5. So I'll show you how it works. So now we have A as 20. 20 is nothing but 0, 0, 0, 1, 0, 1, 0, 0, right? Binary representation. Next we need to do right shift by 2. So what it will happen is, this is the right side and this is the left side. So in the right side, this bit will be popped out, and next this bit will be popped out. Because we need to shift 2 bits, it will be removed. Next here 1 will be moved here, 0 will be moved here, this 1 will move here, this 0 will move here, this 0 comes here, and this 0 comes here. Because 2 bits are moved, this is popped out. Here we can see 2 places are empty. Because 20 is the positive value, we need to add 2 zeros in the left side. This is the left side, right? We need to add 2 zeros. Now this is nothing but 0, 0, 0, 0, 0, 1, 0, 1. That is nothing but 5. So this is the binary representation of 5. That's why here we got output as 5. I'll take A. I'll shift A, a negative value. So let's execute this. I'll get output as -2. So I'll show you how it works. So first I need to write the -6. -6 is nothing but 1, 1, 1, 1, 1, 0, 1, 0, I guess, right? I'll write down this 1, 0, 1, 0. Now we need to shift this to right side by 2. So the first, these bits are popped out, this bit also popped out. Now 0 will move here, 1 will move here, 1 comes here, this one comes here, this one comes here, and this one comes here. Because this is the negative value, I need to add 1 here. Okay, I need to fill these empty places with 1. Now this is the result. So here we can see, so this bit is 1, the most significant bit. So that is nothing but it is a negative value. To find out which value is this, I'll flip this 0, 0, 0, 0, 0, 0, 0, 1. I'll add 1 here. I'll get 0, 0, 0, 0, 0, 0, 1, 0. So this is nothing but 2. And because we flipped this number, this is nothing but -2. This is the representation of minus 2. So here we can see we got the result as minus 2. So in this way, right shift operator works. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.